Good morning everyone, this is group 2 discussing parallel processing algorithm. So we're about to learn the definition, the uses, the types, and the code of parallel processing. And we're also about to learn the subtopics, which is the typical multiprocessing configurations and the process synchronization software. So what is parallel processing algorithm? It is designed to execute multiple tasks or processes simultaneously by using and utilizing multiple processors or cores. The workload is divided into smaller tasks that can be executed simultaneously on a different processor or cores to achieve faster execution time. So how does it work? In general, parallel processing refers to a dividing task between at least two microprocessors. The idea is very straightforward. A computer scientist uses specialized software created for the task to break down a complex problem into its component elements. Then they designate a specific processor for each part. To complete the entire computing problem, each processor completes its portion. Then the software assembles the data to solve the complex initial challenge. So when processing is done in parallel, a big job is broken down into several smaller parts or jobs better suited to the number, size, and type of available processing units. After the task is divided, each processor starts working on its part without talking to the others. Instead, they use software to stay in touch with each other and find out how their tasks are going. So the uses of parallel processing is, for example, supercomputers for use in astronomy. The universe revolves slowly, and astrophysicists must use computer simulations to examine those phenomena since star collisions, galaxy mergers, and black hole ingestions can take millions of years. Such integrate models also require a lot of computing power. Recent advancements in the understanding of black holes, for instance, were made possible by a parallel supercomputer. And also, they are used in video post-production effects. Several high-budget film releases such as Brad Pitt's Ad Astra and John Wick intricately staged assassination preparation depend on parallel processing for post-production special effects. Blackmagic's designs like DaVinci Resolve Studio, among only a few Hollywood standard post-production facilities with GPU-accelerated capabilities, was used in both instances. These powerful computers carry out the state-of-the-art rendering depending on the ray tracing method. 3D animations and color corrections both require GPU parallel processing regularly. So moving on types parallel processing.
There are 6 types of parallel processing. One is SISD or single instruction, single data. Next one is MISD or multiple instruction, single data. Other one is SIMD or single instruction, multiple data. Next, other one is MIMD or multiple instruction, multiple data. And next is SPMD or single program, multiple data. Error siya pagkabutang. Then the last one is MPP or massively parallel processing. So moving on, single instruction, single data is a single processor. It is responsible for simultaneously managing a single algorithm as a single data source. A computer organization having a control unit, a processing unit, and a memory unit is represented by SISD or single instruction, single data. It is similar to the current cellular computer. Instructions are carried out sequentially by SISD, which may or may not be capable of parallel processing depending on its configuration. Sequentially carried out instructions may cross over throughout their execution phases, there may be more than one functional unit inside a SISD computer. However, one control unit is in charge of all functional units, such as system allow for pipeline processing or using numerous functional units to achieve parallel processing. So to explain what is SISD is the simplest and most basic type of computer architecture, which consists of a single processor that executes instructions sequentially on a single piece of data at a time. Traditional PCs and most early computer systems operated on SISD systems. I mean architecture. And moving on to the next slide, MISD or multiple instruction single data. It simultaneously perform many operations as same batch of data. As expected, the number of operation is impacted by the number of processors available. MISD structure consists of many processing units, each operating under its instructions and over a comparable data flow. One processor output becomes the input of the following processor, and then these organizations debut garnered little notice and wasn't used in architecture. Um, the MISD involves a multiple processor which execute different functions or different instructions on the same data simultaneously. And although it is possible that MISD architecture are not commonly used in practice due to its limited real-world application and the complexity of its synchronizing multiple instructions. Moving forward to the third type of parallel processing, which is as SIMD or single instruction multiple data. So have multiple processor that carry out identical instructions. However, each processor supplies the instruction with its unique collection of data. SIMD computers apply the same algorithm to several data sets. The SIMD architecture has numerous processing components. All of these components fall under the supervision of a single control unit. While processing numerous pieces of data, the processor receives the same instruction from the control unit. Multiple modules included in the shared subsystem aid in simultaneous communication with every CPU. This is further separated into organizations that use bit slice and world slice mode. So SIMD employs a single instruction stream to operate on a multiple elements, kana sunod-sunod or simultaneously. The instruction is executed simultaneously on multiple processing units with kanang ang isa ka unit niya kay perform og same ra nga kanang operation pero lain-lain siya data. Yeah. It kanang commonly used siya sa mga application nga nag-involve wait. Kanang mo perform sad og kanang same operation pero large set sa data na iya ha, such as multimedia processing in graphic rendering. Next one is multiple instruction multiple data, MIMD. MIMD our computer it is characterized by the presence of multiple processors, each capable of independently accepting its instruction stream. These kinds of computers have many processors. Additionally, each CPU draws data from a different data stream. MIMD computer is capable of running many tasks simultaneously. All of these components run fall under siya sa usa ka kanang control unit. While processing numerous pieces of data, each processor receives the same instruction from the control unit. So, kanang same ra siya, maka-receive siya og kanang instruction sa kuan na gapon sa katong isa nga control unit. So, multiple modules included in the shared subsystem aid in simultaneous communication with every CPU. This is further separated into organization that use bit slice and word slide mode. So, MIMD is characterized by multiple processors that can be independently or kanang sa tagsya siya execute kanang sa lain-lain nga instruction o kanang sa data niya. Kanang each processor sa MIMD system nasa siya iyahang kagalingon instruction stream na maka-operate siya yung kagalingon kanang set sa data. This type of kanang process is prevalent in modern multi-core processors and distributed computing systems. Next is the fifth one is SPMD or single program multiple data. So each of its processors is responsible for carrying out the same instructions. It is a message passing programming used in distributed memory computer system in which it is a group of separate computers collectively called nodes make up a distributed memory computer. Each node launches its application and use send or receive routines to send and receive messages when interacting with other nodes. System can also use message to provide barrier synchronization. It is very possible to transfer the message via a wide range of communication techniques such as transmission control protocol or over Ethernet and specialized high-speed interconnects such as supercomputer interconnect and MIRIN. SPMD is a variation of MIMD where kanang multiple processors execute the same program on different data. Ang taga-isa ka processor niya kay maka-execute og different parts sa program but nasa siya familiar nga control flow. So, it is also commonly used in parallel computing or what we do na kanang about the topic which is parallel kanang computing where a large task is divided to smaller subtasks that can be executed concurrently on multiple processors. And the last one is MPP or massively parallel processing. It is used to manage the coordinated execution of program operation by numerous daghan nga processor, which each CPU using its operating system and memory. This coordinated processing can be applied to different programs sections. As a result, parallel processing or MPP database can handle large amount of data and deliver analysis based on a large datasets considerably faster. MPP processors typically communicate through a message interface and can have up to 200 or more processors working on the application. It's function by enabling the transmission of messages between processes via set of corresponding links. It also refers to a system with a large number of mga interconnected nga processors, which is explain niya work kanang mo work ka sila sa pero kan siya kanang work sila dungan sa isang task may siya assign. So kanang they can handle computationally intensive problem by dividing the workload across multiple processors. These architectures are commonly used in supercomputers and high performance computing clusters. So each one of the six types of kanang parallel processing, uh, they have their own strengths and weaknesses, which is suitable for different types of application and computational requirements. And that's it for my report. Moving on to the next reporter, Mr. Lenore.
Good day everyone. So I'm Siljan Lenore Lubindino. So we will tackle about the parallel processing code. Here are the subtopics for the parallel processing code. The first one is the typical multiprocessing configuration and followed by processing synchronization software, and lastly is the process cooperation. And here are the three subtopics for the typical multiprocessing configuration. The first one is the shared memory multiprocessing, followed by distributed memory multiprocessing, and lastly is the master worker multiprocessing. Then, what is typical multiprocessing configuration? Is a multiprocessing configuration in a parallel processing algorithm refer to how the processors or cores are organized to execute the workload. So we will tackle the three typical multiprocessing configuration. Then the first one here is the shared memory multiprocessing. So it creates multiple threads or NAM threads to perform computations using shared memory. Then from the word shared memory, ang kaning multiprocessing na una kay ang niya compute niya kay ang mga shared memory gikan sa NAM threads. Then each thread executes the shared memory task function, which simply prints the thread ID. So ang kaning shared memory multiprocessing kay iya jud i-print ang mga thread ID gikan sa NAM threads. So moving on to the distributed memory multiprocessing. So the distributed memory multiprocessing uses the MPI library to perform computations using distributed memory. Then each process retrieves its rank using MPI rank. Then the distributed memory task function is called when the rank as an argument and it prints the process rank. So kaning distributed memory multiprocessing kay mogamit siya MPI library para perform siya sa mga computations sa distributed memory. Then ang gamit sa MPI library para makagamit siya sa MPI rank o para ang mga process gikan sa MPI rank kay ma-print siya by the process rank. Then lastly is the master worker multiprocessing. Then kani kay duha niya yung buhaton, bali one for the master and one for the worker. So master worker multiprocessing creates two threads, one for the master task and one for the worker task. Then the master thread executes the master task function, which print the initial data value. Then while the worker thread executes the worker task function, which multiplies the data by 2. Both threads are joined and the modified data value is printed. So mao to ang gibuhat sa master worker multiprocessing. Moving on to the next one is the typical multiprocessing configuration code. So what is the process synchronization software? to ensure the multiple processes or threads can access shared resources in a coordinated and safe manner without interfering with each other. In a parallel processing systems, multiple processes or threads can execute simultaneously, and if they access shared resource without proper synchronization mechanisms, it can lead to race condition, deadlocks, and other concurrency-related issues. So, from the word process synchronization, dapat ang tanan process nakasynchronize para para during sa mga process kay walay aberya may tabo basta na ang mga process kay hanay lang o nakadepende sa kanang yun sa pag-process dapat hanay lang jud para ang mga may tabo go with the flow lang jud. Then mao ni ang tulo ka process synchronization software na ang the first one is the lock, then followed by mutex lock and the semaphores. So the lock is used to ensure the only one process or thread at a time can access a shared resource. When a process or thread needs to access a shared resource, it first acquires a lock on the resource and releases it when it done. If another process or thread tries to acquire the same lock, it will have to wait until the lock is released. So, ang main purpose aning lock is kanang secure ang shared resources na kanang walay maka-interfere na lain na kuan from the walain na kuan na process gamit aning lock. Then the second one is the mutex lock, used for protecting critical section of code. A mutex provide mutual exclusion by allowing only one thread to enter its critical section at a time. When a thread needs to access a shared resource, it first acquires the mutex lock and releases it when it's done. Other threads that try to acquire the same lock while it is being held by another thread will be blocked and have to wait until the lock is released. So, parihara sila sa lock. Ang kailayan lang ng mutex lock kay pang purpose niya para sa critical section at a time, ang mga critical na section na processes. Then ang lock kay for the shared resources. Then ang role na parehara sa role na maguwat ra sila na mahuman ang lock para makasod ang ikaduha na process. Then ang semaphores is kani kay multiple processes na ang ihandle ni pero depende ra gyapon sa limit niya. So the semaphores used to control access to a limited number. So matong gisulti na limited number of resources, then such as a pool of worker threads that can work on a limited number of tasks simultaneously. Then semaphore maintains a count that represents the number of resources. When a thread needs to be accessed a resource, it first acquires the semaphore. If the count is greater than 0, the semaphore decrements the count and the thread gets the resource. If the count is 0, the blocks until a resource is released by another thread that has finished using it. Then kaning semaphore kay bali na nakaset na ang resources limit niya. Then if greater than 0 palitan if ang resource limit niya kay 4, then ang taga isa ka process na i-handle makuhaan mahimong 3, then mahimong 2, then mo 1. If ma 0 kay ma-block ang mga sunod na process, then maghuwat siya og kanang Ang upat ka process na naisod kay maguwad siya nay ma-available. So, mao ni ang gamit sa semaphore na process lock. So, those are my topics for this parallel processing code.
So, good afternoon, everyone. So, I'll be the one who will discuss the process of operation. So, before ko mo-discuss unsa ning process cooperation, dagan sa tamog simple nga case scenario sa kung unsa nang parallel process o kung kano sa magamit si process cooperation. So, for example, pista sa inyo ha. Pero kani nga pista kay di kay mamapas kundi ang iyong silingan may mamakas sa inyo ha. So, syempre, daghan jud og lutoon nun. So, imbis na ikaw ay maluto sa tanang putahe, patabang kasi mo mga silingan og handa. Then, so na isa mag-chop sa vegetables, mag-imolbo sa manok, hiwa sa baboy. So, by dividing the work, you can finish the meal much faster than if you tried to do everything by yourself. So, mao na siya ang parallel process. So, the performing of tasks simultaneously. However, when multiple processors or threads are working on the same task or accessing the same resource, there's a risk of conflicts and inconsistencies. So balik tas pista, duha ka buok nagtabang og luto sa humba. So pananglitan wa kabalong usa na natimplahan na day sa iyang partner ang humba. So matimplahan sa niya og utro. So ang may tabo, maglalis ang humba ay maglalis ang timpla sa humba. So para mahusay na, then nato magamit ni process cooperation. So process cooperation refers to the use of synchronization algorithms and techniques to ensure that multiple processes or threads can work together without interfering with each other. So para mahusay itong duha, nagkisinabot sila nga usa mo ay tighiwa sa mga lamas ug baboy, then ang usa may motimpla. So this is similar to how synchronization algorithms like clocks and semaphores work in parallel processing systems. So, ang process cooperation pod kay na siya'y gitawag synchronization, which is refers to coordination of processes and to ensure that they access shared resources safe and orderly manner. The next is message passing, which involves sending messages between two processes or threads to communicate information and coordinate their actions. Then the third one is task delegation, which involves dividing a task into smaller subtasks and assigning them to different processes or threads, which enables concurrent execution of different parts of a task and can improve performance and efficiency. So lastly, locks. So these are used to ensure that only one process or thread can access a shared resource at a time.
So now for the last and for the concluding topic, let's have Mr. Ray Alfante to explain the code.
So, good morning, everyone. I'm Mr. Alfante, and I'm here to show you our C program that demonstrates the three types of multiprocessing techniques: the shared memory, the shared memory multiprocessing, and master worker multiprocessing, and pipeline multiprocessing. And here is our code. This code is created in a C program. So, first, in here, this is our library and imports in which this first is the one for that provides our input and functions. In here is the one that provides the standard library functions, and in the PTH thread.h, this is the library who will manipulate and managing our threads. And in here we define a constant variable, which is we assume that we have a number of threads which is 4, and we have a number of data which is 10. And next is in this function is using the SMP or the shared memory task, in which it takes the void pointer arguments as an input, which is letter cast to an integer pointer and difference to get the thread ID, and it then performs some computation using shared memory and prints a message to console. And here, which is the master task, in which it performs a computation of the function master worker, and It takes a void pointer also and arguments as an input, which is later cast on an integer pointer and also. And to show you the output of this code is in here. As you can see, we have these 4 lines, which is printed as the shared memory task, which is the thread 0, thread 3, thread 1, and thread 2. These 4 lines are printed as a result of our execution of the shared memory task, which is in here. And the shared memory task function takes a pointer to an integer as argument, so in which it represents the ID of the thread. And in the main function, we create a thread as pass pointer to their corresponding threads to the shared memory function, and each thread of them prints the message indicating that it is completing the task. So next is in this master worker task, which is the data master processing 20. So this line is printed as a result of an execution of the master task function by the main thread. And the master task function, the rules of it is to take a pointer to an integer, to an integer as an argument, and then represents a value to the shared variable called as the master data. And then the next one is in here, which is the master worker task, which is data after processing is equal to 5. So these 2 lines in here is execution of the worker task, which is in here. And this function is a worker thread in which it takes a pointer to an integer as an argument, in which represents a value of a shared variable called worker data. And in the main function, we create a worker thread in here. And then the master thread and the worker thread operate in the separate copies of the shared variable. So the value of the master data remains unchanged here. So lastly, we have last 3 lines in here. The pipeline task data after stage 2, which is 15. So this line is printed as a result of an execution of this stage 1, in which it takes a pointer to an integer as an argument and then represents the value of the shared variable called data. And in the main function, we create the stage 1 thread and pass a pointer to the data and to the stage 1 function. And the stage 1 function thread multiplies data by 2, which in here. And then value is printed. Next is the pipeline task from the stage 1, in which this line is printed as a result of the execution of the stage 1 function by a stage 2 thread, in which, in here, and the value of the shared variable called data in the main function, we create a stage 2 thread and pass to the pointer of the data of the function, and then adds the 5 data in here, and then the value is printed. And lastly, which is the pipeline task, which is the final data. And in here, this line is printed after both stage threads and have completed all their tasks. And the final value data is printed, which is 30. And note that this pipeline is composed of 2 stages, and each stage operates on in here operates on a shared variable called stage operates, and the one is for the data. And however, this stage thread operates on a separate copy of data, so there's no need to synchronization between stages. And that's all. Thank you.